Hola, chicas. ¿Cómo estás? How's that for a translation?
No, like geometrical translation.
Well, I don't know what you want from me.
First thing we're going to do is review a transformation. That's a change in the position of a geometric figure. So in this chapter, we're going to talk about three different types of transformations: reflections, translations, and rotations. In this particular instance down here, we have our initial figure that we call our pre-image. We're going to talk about that more in a second. Our initial figure, our pre-image, is triangle ABC, and it undergoes some type of transformation in order to get our resulting figure, which we call our image, triangle A prime, B prime, C prime. In this case, it was a translation, a slide. Over here, we have our initial figure, triangle XYZ, which we call our pre-image. It undergoes some type of transformation to end up with our resulting figure, which we call our image, triangle X prime, Y prime, Z prime. In this case, our transformation was a rotation. Now again, we just said the pre-image is your original figure, it's your starting figure, whereas the image is your resulting figure. It's what you get after you take your initial pre-image and perform some type of transformation to it. Now, a vector is a ray possessing both magnitude and direction. And if you've seen Despicable Me, you should have this memorized already. So here you can see we have three different vectors. You can see vector notation down here. This is vector W. And the vector notation, instead of being like a ray where it has an arrow at one end, it's a line segment with half of an arrow on one end. That is vector notation. The vector itself is made up of both magnitude and direction. Magnitude is just the length of each vector, whereas the direction is just where the arrow points. Now, a translation or a slide is a function that maps each point to its image along a vector. So a translation, as you can see, is just a slide. You're going to take each point and slide it along a given vector. So here, our vector X is telling you that we're going to take each point in this triangle here, RST, and we're going to slide it along this vector, the same distance and in the same direction. So all you have to do then is apply this given vector to each point over here. So if I take this vector and attach it to point R, I can see that I'm going to take point R and slide it the same distance and in the same direction. So make sure these are the exact same distance and pointing the exact same direction, and we can put our R prime here. That is the image of point R after it's been translated along vector X. Let's do the same thing with point S. I'm going to apply vector X to point S. I've put it there, and I see I'm going to slide point S along the given vector and put its image right here at the end of the vector. This is S prime, the image of point S after it's been translated along vector X. Same thing with point T. I'm going to attach our vector X to point T and slide point T along vector X to where I get my image. Again, T prime is the image of point T after it's been translated along vector X. There is the image of triangle RST after it's been translated along vector X.
You hear that? It's example time.
Now let's talk about translations drawn with a vector. So there are going to be times where you're not going to be given a figure and a vector on a coordinate plane. You're just going to be given a figure and a drawn vector. So all you have to do then, it's actually pretty simple. To translate a polygon along a given vector, first you are going to draw a line through each vertex that is parallel to our given vector. So I want you to take a ruler and you're going to line it up with point A and make sure that your ruler is also parallel to this given vector. So when you do that, you're then going to trace a line that goes through our vertex A and is parallel to this given vector. You're going to do the same thing for point C. You raise your ruler so that it goes through point C and is parallel to vector W and draw a line like that going through point C. Lastly, again, with point B, do the exact same thing. Make sure your line is parallel to vector W and goes through point B. Then, after you've done that, you're going to measure the length of the given vector. We need to find the magnitude of this given vector, vector W. Once you've done that, you can start at one vertex and measure out the length of the vector and plot a point. So here, at point A, we're going to take however long vector W was. Let's say it was 2 inches. Sure. And we're going to measure out 2 inches on this parallel line that we drew. And that is where our new point, the image of point A, is after it's translated along vector W. So we're going to put A prime right here. C prime. We're going to do the exact same thing. We measure the magnitude of vector W, the length of vector W, and we measure out that same distance here. And we put our C prime, the image of point C after it's been translated along vector W. Same thing with point B. We go ahead and measure that distance, the magnitude of vector W, and we put that point, that distance away from its pre-image point B, and that's going to be where B prime is, the image of point B after it's been translated along vector W. We then connect A prime, B prime, and C prime, and we have our translated triangle A prime, B prime, C prime, the image of triangle ABC after it's been translated along vector W.
Time for you to try.
Okay, we're going to do the same thing here. First, you're going to draw a line through each vertex that is parallel to the given vector. So we're going to draw a line going through each vertex parallel to our given vector y up here. So line up your ruler with point E, and then you're going to draw a line that goes through point E and is parallel to vector y. Same thing with point F. You make sure that your line goes through point F and is parallel to vector y. Line up your ruler with point D, make sure it's parallel to vector y, and make sure that it goes through point D. Same thing with point G down here. Next, you're going to measure the length of our vector, that is the magnitude of your vector. You then measure out that same distance away from each given point. So we're going to start with point E. We measure out the length of vector y along the parallel line that we drew, and we put the image of point E after it's been translated along vector y. We're going to repeat this with points F, D, and G now. So let's start with F. So we measure out the length of vector y along that parallel line that we drew. We put F prime, the image of point F after it's been translated along vector y. Same thing with point D. We measure out the distance of vector y. We put D prime, which is again the image of point D after it's been translated along vector y. Lastly, point G. We start at point G and we measure out the magnitude or length of vector y along that parallel line that we drew. We put G prime, and then we connect these dots. This red trapezoid, trapezoid D prime, E prime, F prime, and G prime, is the image of trapezoid DEFG after it's been translated along vector y. Now let's talk about some translations with a numerical vector. So this is actually way easier. It says, first, we're going to graph triangle RST with the given vertices. So R is at 1, 1. So we go over 1 on the x-axis, up 1 on the y-axis, put a point. S is at 5, 1. We go over 5 on the x-axis, up 1 on the y-axis, put a point. And T is at 3, 4. We go over 3 on the x-axis, up 4 on the y-axis, put a point. There's our triangle RST, and we're going to translate it along vector -4, 1. Well, what the heck does that mean? First, I need you to notice these little brackets right here. These little brackets let you know that this is a vector and not a point. Now, what does a numerical vector tell you? Well, it tells you a couple things. First, it tells you which way to move on the x-axis and which way to move on the y-axis. So we're going to take each point and translate it along this given vector, -4, 1. Now, you can think about it two ways. One would just be in terms of how am I moving this, and the other would be in terms of what am I doing to the coordinates here. The first, how am I moving each point? Well, since this is negative right here, that means that you're going to move to the left 4 units. If it was positive, you would move to the right 4 units. Here, since this is positive, we're going to move up 1 unit. If it was negative, we would move down 1 unit. So again, we're moving to the left 4 units and up 1 unit. If you want to think about it in terms of what am I actually doing to the coordinates of each point, I'm going to subtract 4 from each x coordinate and add 1 to each y coordinate. Subtract 4 from each x coordinate, add 1 to each y coordinate. That will translate each point in triangle RST along this given vector. So honestly, both of these ways will help you translate. It doesn't matter to me which one you use. I'm going to use this one for this example. So we're going to take each point and we're going to move it to the left 4 units and up 1 unit. So I'm going to take point R, move it to the left 1, 2, 3, 4 units, up 1 unit, and that is where R prime is going to be. That's the image of point R after it's been translated along this given vector. Point S, I'm going to move to the left 1, 2, 3, 4 units, up 1 unit. That's where S prime is going to be. Again, this is the image of point S after it's been translated along this given vector. Point T, I move to the left 1, 2, 3, 4 units, up 1 unit. That is where I'm going to put T prime, the image of point T after it's been translated along our given vector. Here is triangle R prime, S prime, T prime, the image of triangle RST after it's been translated along the vector -4, 1.
Stop it! You try!
Okay, doing the same thing here, except this time we have a rectangle and it has points L, M, N, and O. So let's graph each of these. Point L is at -1, 2. So we put a point there. Point M is at -5, 2. We go over -5 on the x-axis, up 2 on the y-axis, put a point. Point N is at -5, 4. We go over -5 on the x-axis, up 4 on the y-axis, put a point. Point O is at -1, 4. We go over -1 on the x-axis, up 4 on the y-axis, put a point. There's our rectangle L, M, N, O. Now, again, I'm translating along a vector. In this vector, we know it's a vector because it has these little brackets right here. This vector this time is 5, -2. Now, what is that telling you? Well, it's telling you two things. Again, the first number tells us which way to move, left or right. So it's moving to the right because it's positive, 5 units. And this tells you where to move up or down. Because it's negative, we're going to move down 2 units. So again, we're going to take each point in rectangle L, M, and O and move them 5 units to the right and 2 units down. You could also think about it in terms of function notation. I'm going to take each ordered pair and I'm going to add 5 to the x-coordinate and I'm going to subtract 2 from the y-coordinate. So let's use this time to translate our given rectangle. I start with point L, and with point L, I'm going to add 5 to my x-coordinate and I'm going to subtract 2 from my y-coordinate. So when I add 5 to my x-coordinate, I get 4. When I subtract 2 from my y-coordinate, I get 0. So L prime is going to be at 4, 0. M prime, if I want to find M prime, I take point M and I add 5 to my x-coordinate, I get 0. Subtract 2 from my y-coordinate, I get 0. So M prime is going to be at the origin, 0, 0. If I want to find N prime, I go ahead and add 5 to the x-coordinate. 5 plus -5 is 0. And then I subtract 2 from my y-coordinate. 4 minus 2 is going to give me 2. So 0, 2 is where I'm going to find N prime. And then O, I take -1, add 5, and I get 4. I take 4 and subtract 2, and I get 2. So I end up getting 4, 2 is where O prime is going to be. This red rectangle, rectangle L prime, M prime, N prime, O prime, is the image of rectangle L, M, N, O after it's been translated along this given vector. Now, example 3 says use function notation to describe the translation of the blue preimage to the red image below. So we're starting with this blue triangle right here, and we're going to end up at this red triangle right here. So function notation looks something like this, where we have a point x, y, we have a little arrow, and then over here, it's going to tell you what to add or subtract to your x-coordinate and what to add or subtract to your y-coordinate. So we first need to figure out what the coordinates of each of the points in our pre-image and our image are. So we'll start with this point right here. We'll call it A. A is going to be at -9, -9. Now, its image up here, that same point translated, is going to be at 4, 2. So we'll say A prime ends up at 4, 2. Then this point, we'll call point B. Point B is at -5, -9. Its image up here ends up at 8, 2. So B prime is at 8, 2. Our last point in our pre-image, we'll call it C. That is at -6, -6. And our image of point C, we'll call that C prime, ends up at 7, 5. Now that I have all the ordered pairs in my pre-image and my image, I can figure out what this translation looks like in terms of function notation. So the only thing I have to do is just figure out what do I have to add or subtract to each of my x-coordinates in my pre-image to get the x-coordinates in my image. And the same thing with the y-coordinates. What do I have to add or subtract to the y-coordinates in my pre-image to get the y-coordinates in my image? So let's look. Let's start with point A. What do I have to do to get point A from -9, -9 to A prime at 4, 2? So let's start with the x-coordinate. What do I add or subtract to -9 to get it to be 4? Wouldn't I add 13 to -9 in order to get 4? Yeah. What about the x-coordinate for B? What do I have to add or subtract to -5 to get 8? Well, I add 13, right? Same thing with C. -6 to 7, I add 13. Yeah, so x plus 13 is going to be the x portion of my function notation. What about the y-coordinates? What do I have to add or subtract to the y-coordinates to get the y-coordinates in my image? Well, going from A to A prime, I'm going from a -9 y-coordinate to a +2 y-coordinate. So I'm adding 11. What about B to B prime? I'm going from -9 to 2. So again, adding 11. And then from C to C prime, I'm going from -6 to +5. So again, adding 11. So let's see if that checks out. If I use my function notation to translate each point, let's go with A. I go to the right 13 units and then up 11 units. Yep, that works. For B to B prime, I go to the right 13 units and up 11 units. Yep, that checks out. And then C to C prime, I go right 13, up 11. Perfect, did it right. Part B, this time we are given the coordinates, but we are not given a coordinate plane. It works the exact same way. You just look at the x coordinates in your image and then figure out what do you add or subtract into the x coordinates in your pre-image to get the x coordinates in your image, and then what do you add or subtract to the y coordinates in your pre-image to get the y coordinates in your image. Well, let's start with the x coordinates. So here, we're going from -4 to 2. We're going from 2 to 8. We're going from 2 to 8. We're going from -4 to 2. So what do I have to add to -4 to get it to be 2? What do I have to add to 2 to get it to be 8? Same thing here. Same thing here. It's 6, right? So it's going to be x plus 6 in my function notation. Now let's look at the y's. I'm going from 4 to -6. I'm going from 4 to -6. I'm going from 0 to -10, and I'm going from 0 to -10. Well, it looks like this is probably the easiest one to see. I'm going from 0 to -10, so I'm subtracting 10. So it should be y minus 10. And that is the function notation for this translation.
You better try this right now!
Okay, doing the same thing here. We're going from our blue pre-image to our red image, and we want to use the function notation to figure out how do we get from here to here. Well, we start by figuring out what our coordinates are in our pre-image and our image. So our coordinate, let's call this one W, is going to be at 2, 5. Its corresponding point in the image over here would be at -9, 1. We'll call that W prime. We'll call this point X at 7, 5. And then its corresponding point over here in the image would be at -4, 1. We'll call that x prime. We'll call this point y. Y is going to be at 7, 8. And then its corresponding point over here would be at -4, 4. We'll call that y prime. And then we'll call this last point z at 2, 8. And then z prime is going to be this last point over here, the image after this is translated, and it's going to be at -9, 4. Now what's left is to figure out what am I going to do to my x and y coordinates in my pre-image to get the x and y coordinates in my image. So we'll start with W. Going from W to W prime. I have a 2 as my pre-image, and I have a -9 as my image. So what am I doing to 2 in order to get it to be -9? I'm subtracting 11. What about going from x to x prime? I'm going from a 7x coordinate to a -4x coordinate. I'm subtracting 11 again, right? 7 minus 11 gives us -4. What about going from y to y prime? Going from 7 to -4. Again, I'm taking 7, subtracting 11, and I get -4. That works too. And then lastly, z to z prime, I'm going from 2 to -9. So we are again subtracting 11. Perfect. So down here in our function notation, we write x minus 11. What about the y coordinates? In W to W prime, I'm going from 5 to 1. So I'm subtracting 4. Going from x to x prime, I'm subtracting 4. Going from y to y prime, I go from 8 to 4. I'm subtracting 4 again. And then z to z prime, I'm going from 8 to 4 again. I subtract 4. So it should be y minus 4 here. And we can double check. Does this make sense on our graph? So going from W to W prime, I go left 11, down 4. Yep, that's where W prime is. Going from X to X prime, is that over 11, down 4? Yes, it is. Y to Y prime, over to the left 11 units, down 4 units. Yep. And then Z to Z prime, over 11 units to the left, down 4 units. Yep, perfect. We did it right. Awesome. Now part B, we're doing the same thing. So we need our function notation, and we need to figure out what are we doing to our blue ordered pairs in our pre-image to get them to be our red ordered pairs in our image. So we'll start with the x coordinates. So I'm going from 1 to 1, going from 3 to 3, and going from 4 to 4. So what am I adding or subtracting to my x coordinates in my pre-image to get the x coordinates in my image? Looks like nothing, right? So it's going to be technically x plus 0. What about our y coordinates? I'm going from -5 to 2. I'm going from -2 to 5, and I'm going from -8 to -1. Well, this is probably the easiest one to see. I'm going from -8 to -1, meaning that I am adding 7 to my y coordinate in my pre-image to get the y coordinate in my image. So it's giving me y plus 7 here in my function notation, and I'm done. Now the word problem says you are playing Tetris and the purple tile piece appears at the top. You want to fit it in the specified location. If the starting point of the purple tile piece at the top of the screen is x, y, use function notation to describe the translation that it will take to fill the indicated row. So here's our function notation, and again, all we're doing is figuring out how far to the left and how far down does this puzzle piece have to go in order to fit into this spot. Well, let's start with how far left. So it looks like we're going to move it to the left 1, to 3 units. And if we're moving to the left 3 units, that would be subtracting 3 from our x-coordinate in our function notation. So that looks something like this when we move it to the left 3 units. Now we need to move it down in order to get in this spot. And how far down? Well, it looks like we need to move it down 1, 2, 3, 4 units down, which would mean we are subtracting 4 from our y-coordinate over here in our function notation. And if we move it down 4 units, does it fit in? Yes, it does. Therefore, this is the correct function notation to describe our translation of our given tile piece.